So now we're going to demonstrate xSCOPE, and briefly, xSCOPE is a tool that allows you to trace data in real time off the chip, and it allows you access to all the data inside of your running system. So this is the XMOS slice kit. We have the X tag plugged in, so this is acting as the debug adapter, and this talks to the host via the USB cable. Here we have two slices plugged into the slice kit. We have the audio slice and the SD-RAM slice, and then the mobile phone here is acting as an audio input source. So when it's working, the audio input comes in from the phone across through this channel. The XMOS device here is reading the samples in, it's doing some DSP, it's using the SD-RAM as a buffer while it's doing that DSP work, and then it's outputting the output samples across this channel out through the wire to a speaker. So we want to use xSCOPE to actually visually see the samples, both the input and the output samples, so we can visually verify that they are what we expect given the DSP work in between. So the first thing we need to do is actually annotate our code to show that to enable xSCOPE. So we need to register two probes, one for the input sample, one for the output sample. This is done here. And then in the actual place where we want to sample the data, we call the xSCOPE probe data function. And this is sampling both the input and the output audio. Then when we run xSCOPE, we should be able to see both the input and audio samples on the screen. And here they go. So the input sample is the purple one, the output sample is the orange one. In this case, they're exactly identical because there's really no DSP going on in between. So we can separate the samples in this way, and then we can see them both visually on the screen. So this view also allows you to set trigger points, much like you would in a hardware scope, such that when the value hits a certain level, the sample hits a certain level, it freezes and you can investigate the values either side. So to sum up briefly, xSCOPE gives you the ability to visually see what's going on inside the chip in real time.